Okay, so when we're sketching cubics, there are three really important things to think about. First off is the general shape. Second is where the curve intersects the y-axis. And lastly, where the curve intersects the x-axis. So just like a quadratic, three main things to think about, but this time obviously it's a cubic. So the shape of a cubic, right. A positive cubic graph starts from the bottom right, bottom left even, and wiggles its way up to the top right. So this is y equals x cubed here. A negative graph obviously then works in the opposite direction. And it runs much the same way as a linear graph does. So if we had just the graph y equals x, that would run in a straight line. In the same sort of direction. If we had y equals minus x, again it would run from top left to bottom right. So they follow similar sort of patterns. Okay, and the y-intercepts then, well, this is the place where our graph crosses the y-axis. So if we have that y is x cubed plus 2x squared plus 7x plus 4, we know that's a cubic because of the little 3. And where it crosses the y-axis is when x is 0. So y is 0 cubed plus 2 lots of 0 squared plus 7 lots of 0, well, plus 4. So y is 4. So in this graph, our cubic, whatever it's doing, is crossing the y-axis at 4. So it's when x is 0. Possibly then the most tricky thing is thinking about the x-intercepts. But if we think about a quadratic for a moment, when we find two solutions, x plus 2 say and x minus 3, and that was our factorised quadratic, we'd then set that equal to 0. And why we would do this is because we want to know where or which points the graph crosses the y-axis, which is when y is 0. So we'd get that x plus 2 is 0 or x minus 3 is 0. Now in this case, therefore, our graph would cross at 3 or minus 2 and look something like that. Now obviously we're not dealing with quadratics, so I'm going to move that out of our way for a moment. We'll think about cubics. But cubics behave in much the same way. If we're interested in where the graph is crossing the y-axis, i.e. where if we're interested in where it's crossing the x-axis, i.e. where y is 0, then we actually want to set the equation to be 0. So 0 is x plus 2, x minus 3, and x plus 4. Now, three things multiplied together equaling 0 means one of them has to be 0. So either x plus 2 is 0, x minus 3 is 0, or x plus 4 is 0, in which case x is either minus 2, 3, or minus 4. And what does that actually look like in a graph? Well, we know what shape a cubic graph is. It's either going to be going from bottom left to top right or top left to bottom right. This one is positive because we've got our x cubed term, if we were to expand it out, would be a positive one. Therefore, we're going to start in the bottom left-hand corner and finish in the top right. And we know that it's going to intersect the x-axis at x is minus 2, x is minus 4, and x is 3. And then it's basically a case of playing dot to dot. So we're going to start in this bottom left-hand corner and make sure that we cut through all of those points following the general shape and shooting off into the top right-hand corner. And there you have it. That's that particular graph drawn. What about this second one then? So let's follow the process through again. 0 is x plus 2 squared x minus 1. So either x is minus 2 or minus 2 again, or it's 1. Now this is a little bit tricky to think about, but hold your horses for a second. If we have got a crossing point at -2 and then at -2 again, what that means is if we zoom in on that spot, on this little spot here at -2, what's actually going on is that our graph is going to cross through and cross back up through that graph in that infinitesimally small point. So it's not actually going to cut through the x-axis at all and then cut back. It's just going to look like it's touching it. So it's merely going to just hit the graph at -2, and that's what that repeated route will look like. And then we know that that graph is also going to cut through at 1. So we've got -2 and 1. Now, again, x squared in the top brackets is multiplied by a positive x if you were to expand all those brackets out. So we know we've got a positive cubic graph. So we're going to start in the bottom left-hand corner, and we're going to come up to -2, but we don't want to cross through it. We just merely want to touch on it. And then we're going to bend back through, and then this is a single root. We've got no repeat of 1, so we're just going to cut straight through. Now, obviously, my drawing there was terrible, and yours will be far better, of course, but you get the idea. Lastly, then, we've got a point where actually we've only got one root, so we know that if we were to set x is 0, y is 0, then x would be -2, -2, or -2. Right, okay, let's zoom in on that spot again. So our graph is cutting through, and then back through, and then through a second time, all on the same spot. And that's quite hard to visualise, but actually it looks like exactly what a standard cubic graph would do, which is to have a point of inflection. It just kind of hovers on the spot. So in this case, though, we're hovering at the spot x is -2. So hopefully that's given you a good idea of what a cubic looks like sketched. Make sure you've drawn out diagrams in your booklets and be ready to think about these graphs in terms of graph transformations in the next couple of videos.